We'll just wait for a few minutes and we'll start.
Sure. Manish, sir, did colleges started again physical or it's still?
No, it's started right now, but students are not yet coming. They will gear up in this week or in next week. So gradually, students will come because of the hostel facility is not available for all right now. So only last year students are allowed to come on the campus in the university, but in colleges they are coming because in colleges they don't need hostels. So the colleges they are coming. But wherever the hostels are required, so on the university campus, only last year students are allowed to come. So here the situation is becoming very normal.
Okay.
So maybe in next few weeks it will be all right.
Hopefully there won't be any new variation now.
Yes, yes.
Has been crazy.
How is situation there?
Situation is normal, Manish, sir. There isn't much stress as such.
Okay.
The I haven't seen many cases as well
Mhm.
recently. Uh, Mostly home tests are happening. Nobody's doing the actual RT-PCR test, so the results or the infection
Yes.
rate is not much visible right now. Okay, so everything is just presumed. So let's see what happens.
And it's not that fatal, no, now.
Yeah, it's not that terribly bad. The severity as well as the overall health impact has not been that detorious. So people have been taking it very lightly.
Right.
Not long.
That's good.
Let me know whenever you want to start, no, Manish sir. Okay. So we are still waiting for 22
Yeah,
more
just
attend.
2 minutes. In 2 minutes we'll start.
Okay.
The people join little late, maybe. So they should not miss your introduction. Okay, all right. So let us start. Just a minute. So good morning in India, and it's Thursday night for Nilesh, and I'm thankful to him for joining late night to this course to deliver his experience, his share, his thoughts, and as you can see his introduction on the screen. Uh, I have to add a few points which are not mentioned here. Is student of Kavitri Bhainabai Chaudhary North Maharashtra University. After completing his post graduation, he struggled a lot, and then he is a result oriented guy and has delivered a lot. In many areas he delivered. He is, as I said, is a result oriented. So he generally worked in fintech companies for health domain, and he is a master of handling big data. In his talk, he is going to share some case studies that will be helpful to us to understand the big picture of this particular area and how it is transforming overall industry. So Nilesh is a most appropriate person or resource person that who could deliver and who could give insight to the academicians like us from the industry perspective. So I really uh, happy to have you and to share. We would like to see and understand what is your take on this data science. Now he has more than almost 20 years of experience now in this industry, and is at a higher management level in his company. So I really appreciate your efforts, and I really appreciate the way he responded to my request, because it's like late night for him in US, and he agreed to talk with the teachers who would be giving their exposure whatever they got to the students. So I really appreciate Nilesh, and thank you for joining us, and I request you to start your presentation.
Sure, sure. Thank you, sir. Thank you. I appreciate it. Okay, so let me start this way. Okay, so I will try to cover few basic principles about big data analytics. So there is lot that has been spoken about big data as well as data analytics and data sciences, but it is important to understand really what constitutes to a big data and what does not. Unless the data foundations are clear, it will be very difficult for people to really leverage that data for the analytical purposes, whether it's analysis, whether it's a data sciences, or whether you are doing the advanced engineering using machine learning techniques or AI techniques. So what I'm going to cover today is like what is the fundamentals about big data, why it is important, what sort of use cases you should think about big data, and who are real consumers of the big data, right? These are some of the key items that we are going to go through. So it is essential to understand for anybody who wants to talk onto the big data or want to educate people onto the big data, that what does really require when you walk onto the big data programs. Okay, whether you are getting as a big data engineer or whether an organization is starting to adapt to a big data initiative, or somebody like a consortium where the data aggregation is happening across the board and you are trying to leverage that data for doing a benchmarking, predicting the futures about any variables or variables essentially that are going to drive some level of initiatives, right? We will also go through where does big data come from, right? What are typical sources of the big data? Not everything is big data, right? Not everything. Yeah, not everything should be considered as the big data, right? Now there are ton of technologies and tools that came over last 10 years into big data ecosystem. You'll be surprised if I give you the numbers. Traditionally, ETL, the concept that we had extract, transform, and load tools, we had 7 tools in the industry. Today, for similar work, we have 3,897 ETL tools and technologies available apart from the scripting. In a scripting, you got another 2,500 different scripting technologies through which you can do the similar activities. Now, with a such vast level of technologies available, how to select the right tools is a critical for people to understand when they try to design, develop, or implement any big data solutions. So we'll touch base onto that little bit. Then there are some techniques, right? It is not just about writing the SQL, creating the report, or creating the Excel sheet out of the data, right? It is about uh, deploying the right technology, techniques, and tools to predict or to visualize or to even identify or analyze the data sets, right? So there are different segments of the data analysis that we will talk about. Then there are key benefits, some of the successful implementations of the big data that uh, I have done personally. So I'm going to talk few of those. I will try to make it as much as informative as possible. Okay, we will do much more deeper technology discussions as well, or probably just walk you through some of the reference architectures which are considered to be a patents of each cloud services provider, right? So first of all, let's understand that big data is not a Hadoop. Okay, Hadoop is a technology platform which allows you to implement the big data components, right? So whenever I say big data, it does not mean a Hadoop. Okay, so when big data came into picture, probably around 10 years back, when the first time concept of big data came, people were not sure really to what to call a big data. Okay, whether it should be a size based, whether it should be on a velocity, whether it should be based on the veracity, right? So volume is one part, right, through which you can say that, oh, I got a large data set which is a big size. So that could be one, but really does that enough to say that, okay, I have a big data? Not necessarily, right? So big data has a volume which is 25% that defines the big data definition, but 75% definition comes from the velocity as well as the variety or the veracity of the data. As organization has started collecting more and more data over years, this data has grown to a size that traditional tools and technologies could not really handle the analysis requirement. Now, if you really look at how people used to analyze the data, mostly reports, just create the list report using any of the tools, something like, let's say, Cognos, Business Objects, or even SSRS, Power BI, Tableau, all of those tools, right? Those were getting used to create the kind of reports that will tell, okay, what happened into my business, right? As industry started evolving over a period of time, they realized that what I'm really looking at is what is going to happen to my business, right? What will happen to my population? What will happen to my consumer? What will happen to my entire infrastructure? So really looking at the historical data and predicting the future in terms of what if, in terms of basically the probability based predictions, or even something like decision support systems. Now, when that concept started coming up, okay, people realize that moving data from one place to other place takes a longer time for me to analyze that data. And data in organizations is always scattered. So let me give you an example. Morgan Stanley, which is one of the leading uh, capital market banks, investment bank, they got 6,800 different data warehouses across the globe. Now, there is no way somebody can really get all the data into one place to realize all the analytical requirements. So data movement become very, very complex for large organizations. Now, that also put a lot of pressure onto the organization to spend more money to consolidate all data, which they could not do. So how to really minimize the data movement really created the thought process for inventing the big data technologies, right? The second challenge that industry started facing, that the traditional techniques of writing SQL queries, creating reports were not just enough, right? So organization had to really think about, okay, what my new data sources are going to come from, what existing skills that I can really use versus what new skills that I will have to bring in, how I will cross skill the workforce. as well as lot of academic institutions started thinking how to really start seeding some of these techniques and technologies and skills into the new age skills, or the employees or potential resources for the IT industry can be really groomed into. So that is where the whole concept of online trainings for the big data started, right? And then last one, as data was moving, the bigger concerns started coming for people, that how to really make sure that my data is secured. Now we generally don't worry much about, okay, the data in India, but if you really start looking at some of the large enterprises within India as well as outside of India, they take data security is very they give major focus basically, right? So when data security comes, it is not just about making sure that data is encrypted or password protected or stored into the secured location. It is about how your data is moving from one place to other place, whether the encryption at rest as well as encryption into the movement of the data is done or not, whether my protected information is desynthesized or obfuscated or not, right? So some of those bigger concepts started coming up, and that created this market requirement today, what we call that as a big data analytics uh, wave, that everybody wants to be a data scientist, everybody wants to be a data engineer or a big data engineer, right? So genesis of that, as companies started increasing to capture the data over a period of time, that data started growing. Today, as on 2021, uh, the data growth factor is 120 times faster as compared to what it was 10 years back. So imagine that if there were 100 records that were getting generated today, those are 12,000 records approximately getting generated every day, every second, in depending on the type of the organizations or type of the industries that you are onto. Now there are 4 or 5 core data generators, or where the data really starts getting originated. There are applications and products. There are devices, wearable devices. Now even the smart devices which people wear, but there are ton of devices which are not connected or not wearable, but they do generate a lot of data. Example of that is just your Wi-Fi router, right? The amount of data that generates for the internet service provider, ISPs, is just enormous amount of data that goes to them, right? There is a bidirectional up, always happens. So there is a lot more data which is not non-variable that also generates. There are external data sources which you don't know, but you are implicitly or explicitly generating data using, right? Your electricity meters example, right? They generate a lot of data, right? Your all vehicles today have the smart devices into that, all of that data, which are the external data sources which getting used for a variety of purpose. Now when you look at all this data, there are three different type of data sets that you can really classify them into. One is a transaction, where a individual initiates the transaction or the record. Example, I withdraw money from the ATM, okay, or I go to the doctor and doctor captures my visit, captures my diagnosis. Those are the transactions. Whereas when transactions are happening, there is in a back end lot of logging data that gets captured. What happened, whether password was entered or right, which ATM that you used, which hospital that you went to, what time you went to, all of that information, which is the supportive information to prove that these transactions were legitimate, right? And then there is a ton of emails and other documents that gets generated within the entire ecosystem, that creates a large volume of data sets within the organizations, right? Now when I'm saying organization, you can imagine any company, any institution, be it the educational institution, whether it's a banking institution or whether it's a corporate or manufacturing institution, right? So all of them generate these three type of data sets. Today 88% of data that gets captured is the transaction based, but there is equal number, almost 73%, almost equal to the number of transactions that gets generated by the log data. Now there is a whole new world of the social, audio, videos, photos, images, all of that that gets generated and gets leveraged to complement the businesses. So that data becomes very important. Example, I can tell you, let's say uh, a consumer calls to a contact center, right? Uh, for bank, the moment you call, okay, they will ask you, for example, right? Can you verify your zip code or the pin code where you are calling from, your address, all of that information that comes to the transactions. But while they are doing it, okay, based on the geographical location that you are into, they try to capture as much of social data that they can, to make sure that if there are advisory or there is some level of alerts that they need to send you, they will send that to you, right? So those are the social data, social elements. Healthcare world, social determinants of health creates a big impact, right? Which area I live into, what will be my food habits, what type of restaurants are there, what sort of medical centers are there, what sort of pharmacies are there, what sort of businesses are there, that defines my lifestyle, and lifestyle has a bigger impact onto the healthcare. So they try to capture all that data, which is considered with the external data, right? Now, if you look back and think about data warehouses that we used to build in the past, we used to always think about the database tables, right? Now there is 70% of that data that comes today can't be entered or can't be stored into the relational stores. So the thought process started that, okay, how to really manage that? And that is nothing but your documents, right? So that is where the NoSQL databases came, which are massively parallel processing platforms, which allows you to process data in a much faster way as compared to what you used to do using Microsoft SQL Server, Oracles, IBMs, or Foxpros of the world, right? If I go really 20, 25 years back. So all of that data. Now, imaging become a very, very big, large data set that organizations as well as industry experts do use for research. A classic example of that could be a dentals, right? Uh, Initially, dental imaging, nobody used to bother much about that. Doctor used to look at it and throw it. X-rays, they will look at it and just put into the file, and then after 6 months, if you go, nobody bothers about it. Now that doesn't happen that way. So all this imaging data gets used to determine variety of predictions for the individual. So, and 2 weeks back, we ran into a great case study that we implemented for one of the leading health system here. Health systems are the hospitals, where we were looking at the bone uh, density as well as bone strength, looking at the past x-rays of the patients of similar ethnicity, similar lifestyle, similar age, and had similar events or similar incidents into their life, to say that, okay, what is the potential for individual X to have a knee replacement surgery in next 3 to 7 years. Now, when you process this data, you can't just look at the database tables. You got to look at the imaging. You got to look at their diagnosis. All of that data needs to be processed in a near real time. That is where, if you look at the entire industry's data segment got distributed into, right? So all those data, there are organizational specific data, and then there is a general big data ecosystem that exploits the overall architecture of the big data systems. Emails, for example, every second there are 2.9 million emails sent onto the, from variety of ways, like whether public domains or private domains. There are tweets, 50 million tweets per day that happens. There are about 72.9 items or products are ordered onto the Amazon per second, right? So imagine the number of transactions that are happening. All these transactions has other data set that also that gets associated with who ordered, when ordered, what was the price, who is going to fulfill the order. So it starts fanning out. So when you talk about one entity, that entity results into multiple touch points. Each touch point can cause a multiple set of entities. So that's how the big data explosion that has been happening. The reason I'm talking all about this, that where data gets generated, how that data gets used, all of that needs to be thought through when you design the technical architecture to solve a specific problem. It is important also to understand that big data is not a solution for everything that comes your way. You got to make sure that people who are going to design the system, you educate them that big data is a technique, not a solution. Technique can be used to solve the specific problem. That is where I'm going to talk a little bit about use cases which we have solved into the past and which has been across the industries being very well accepted as well as being seen as the proper big data implementations. So you take any industry, be it the healthcare industry, banking industry, retail industry, hospital, the entire hospitality business, or any other businesses that you take, right? The 360-degree view of customer is very, very important. Now, today when I log into Amazon, Amazon knows everything that I have done uh, on Amazon as well as the other competitors, what I have purchased from them. What is my likeliness based on what others have purchased that I will buy a certain product, that they try to highlight that to me. So they can do that because they have seen my behavior, they have understood my buying potential, they have looked at the potential of what sort of products are available into that geography, which could be add-on or supplementary for the products that I purchased into the past. So the associativity rule that we used to apply into the data mining, that is very much applicable, and that happens when you look at the consumer data and try to stitch a complete longitudinal record set for the individual. That is nothing but 360-degree view of customer. Now, has every industry solved this problem? No. There is a retail industry who has solved this problem to a good extent. They're still trying to expand that, but all other industries are yet to really get there. Healthcare is another ecosystem which requires major uplift to get the understanding of the consumer so that they can give a right care, they can predict right clinical needs for the individuals, right? Banking industry has used only financial data. They haven't really used other data sets, right? So how to really leverage some of those are the use cases that industry is trying to solve. Customer acquisition and retention is very, very important, especially for the businesses which are non-SaaS, sorry, my bad, especially for the businesses which are SaaS based, be it the mobile application. If somebody downloads the mobile application, how to really make sure that they use that application and you are able to retain them and they don't delete the applications. That's how this mobile app or SaaS companies make money. So that requires a good understanding about the customer, how to make sure that the customer is attracted to your application. It requires again some additional data to be processed. That causes it to be a big data. Fraud prevention across the industries, be it the cybersecurity, banking, healthcare, email frauds, or even the educational frauds, right? How to really prevent that, right? Every year, United States pays about $36 billion into the frauds. There are so many incidents that happen. So there is so much of new progress that is happening onto how to leverage the big data to avoid that sort of fraud. Uh, Waste is another use case that everybody is looking at. In a healthcare, we solve that for many of our customers, where uh, if let's say and US healthcare is slightly different than the Indian healthcare, the way services are being rendered, everybody is insured. Insurance companies have the network of their providers. Any patient who is covered under that insurance is expected, not must, is expected to go to only those doctors which are into the network. Now, what network doctors do for certain services or specialty, they recommend patient to go to the different doctor which is out of the network, right? And that causes a lot of waste as well as opens the potential for the fraud, waste, and abuse. How to really predict that? Looking at the provider behavior, looking at the patient behavior, and making sure that we are not the healthcare insurance companies are not wasting money onto something which was not really needed. So how to avoid that? Some of those use cases are there. Internet of things, IoTs, like as I said, devices. It is not only about the wearable devices or mobile devices. There are ton of other devices which generates a lot of data. All of that data is very, very important to create the longitudinal record set for an individual, be it a person, be it a product, be it the place, right? Or be it a even price, how to determine the price. So all of that data is very, very important, and that stitching of that data is very important for all sort of organizations. Any questions so far? And I'm still setting the context before I get into the architecture and technical discussion.
No, sir.
Awesome. Okay. So now when you look at the data, right, traditionally we have been, as I was saying, that we used to leverage the reporting tools or SQL tools, right? Now it's a age or era where discovery tools are very, very important. Nobody wants to go through the 10,000 records to identify whether Nilesh Patil has paid his EMI and will pay the EMI next month or not, right? They just need deploy the model which will tell me who have been my regular non-paying customers, what is chances that they will not pay for next 3 months, so that that population is handled differently. It's called discovery tools. The traditional tools are not very very useful. So there are new age tools that came, which are nothing but the statistical based modeling based, probability based algorithms, or even simple discrete mathematic algorithm that really gets applied onto the data set. The traditional BI reporting tools are not important again, right? The way we used to show the information, and I remember when I did my first product development ERP, the only type of report that I used to get is, okay, what product was used for what and how much of it was sold to, a very detailed list report, right? Now nobody wants to look at the list report. They want to really look at the techniques to visualize it. Show me chart based data set. Now charts also were getting used for last 7 to 10 years. People have been extensively using, but they were not able to take the decisions. Now what came there as a new BI tools are more about how I can give the interface of NLP. I will just simply query, tell me in a particular zip code what is a product that is worth selling as compared to the base selling product, right? I will type a simple English statement and it should show me the result set in a visually representable, as well as if I have to, it should just create the subset of data for me, right? Now that sort of BI tools that came on top of this big data, so that you can really leverage the power of the technology as well as cloud infrastructures that has been provided. Legacy world, we were challenged with the infrastructure, that we used to have minimum memories, minimum horsepower for the processing, as well as storage. Now those bottlenecks gone, right? uh, 6 out of 10 consumers are open for the cloud, 4 are still conservative, but they are still open for learning how we can use it, still protecting my data security. So the discovery tools led to change into the BI tools as well. Now, all of this requires, as I was saying, that discovery, the type of discovery and type of visualization or querying that consumers are looking for, uh, that needed a platform which allows the massive parallel processing with the data. The first one was launched as a Hadoop, and that's why people think that Hadoop is a big data. It is not, right? So Hadoop is one of the technologies, and there are about 8 different platforms, MPP platforms. On that MPP platforms, there are more than 25,000 different technology tools that you can employ to realize your big data solutions. There are some out of the box, like AWS provides, Google Cloud provides, Azure provides, as well as IBM provides. Uh, and those are base platforms. On top of that, you can build as much as that you want. And I'm going to walk you through some of those, right? Now, when industry started realizing, and I'm talking about recent 3 to 4 years, okay? In last 3 to 4 years, the industry realized that looking at these dashboards are not going to help me. How my operational processes and business processes can be augmented based on the insights that discovery tool generated on top of these MPP platforms. how I can augment my all business processes. And I will give an example of that, right? If you call your bank again, okay, they will ask you your account number or PAN number, you validate them. The moment the validation happens, right, a contact center agent or the call center agent gets the alerts on their screen, which tells that, okay, Nilesh Patil is a good candidate for selling a particular type of credit card. He likes vacationing, so probably giving him vacation package along with the credit card welcome kit will really motivate him to get him onboarded. Nilesh has paid all his past EMIs and credit card payments across the board. Looking at the civil report, he has potentially uh, pre-approval for certain loans as well. Now, all of these things comes immediately so that the contact center can really try to do the upsell or a cross sell, right? This is the business process augmentation. Another example, let's say if you go to a doctor enters and validates your name, your membership number or your MRN number, medical number. Immediately he sees that, okay, Nilesh had missed 2 visits. He has been missing a particular vaccine. He is onto so and so medication, and he also has a potential or probability that he will get diabetic into next 3 years, and his cost is going to get uproar by, let's say, 200%. So doctor can really create a custom care plan for me, right? And there is auto generated care plan also that we can generate. So all this is nothing but called as a in database analytics or augmented analytics or inline analytics, which directly influences your decision management. Now, when you look at all these 5 pillars of big data and the tools and technologies and techniques that are being used, you will understand the type of skills required to work onto this ecosystem. But if I have to summarize, there are only 3 unique skills that people have to develop. First one, very strong engineering mindset, right? That there is no problem that has not been solved. All of these problems are solved in a bits and pieces by many people, right? So engineering mindset is about really understanding your problem, what are you solving for, and why it is important to solve. The second most important, the data analysis skills and the curiosity that a person must have about a data. Whenever you look at the data, right? The third one, which is more like a scripting skills. Everything into big data is a scripting or configuration. A person who has good scripting skills, be it the C language, C++, Java, Spark, Scala, Python, PySpark, Scala, any scripting, right? If the fundamentals of that persons are clear, they can become a big data engineer. But the first one is very important, the engineering mindset, right? Now, some of the techniques which requires more analytical skills, right? First one was the data engineering, the big data engineering skills, and then there is the analytic skills. The analytic skills in today's world are more about leveraging the statistical analysis, sentimental analysis, good understanding about your classification models. And there are ton of generic models which are available. Person should be able to understand the statistical fundamentals behind why certain algorithm works into certain condition. Now, if I say that classification, when you classify things, when there are more than 2 type of objects are available, be it a people, person, places, products, or prices, right? When there are minimum 2 categories, then the classification comes into the picture, right? But regression comes when it is one person and you're talking about his behavior or her behavior or that product's trend over a period of time. That becomes the regression analysis, right? So somebody needs to really go through that basis, what type of algorithm or analysis makes sense on what type of data. Now we used to, like, I remember when we were in my masters, Nitin Patil sir used to tell us that when you talk about any chart, how you determine which chart works best. pie chart versus line chart versus bar chart versus any other chart. How you define that? Based on the variables that you have. If there are more than two variables, then it's a pie chart. If there are only two variables, then there is a bar chart. But there are multiple variables with a two axis, then the multiple pie charts, right? Oh, sorry, multiple bar charts, right? Or the stack chart. So similarly, that logic needs to be applied onto looking at data set. What sort of statistical analysis method that I need to employ onto? The sentiment analysis is the only one which works when there is scattered data set, where there is no specific data format or specific number of variables available. Example of that, a individual like me can go through various moods within 5 minutes. At 1 second I'm excited, the other second I saw something and I got into the more uh, like aggravated mode, and then all of a sudden I feel somebody just consoled me and then my mood is okay, right? I can go through multiple type of sentiments. When we call to a contact center, let's say your network is not working, or let's say your food delivery is not done on a time, we go through that all agitations, and finally when they say, oh, we are sending ice cream complimentary to you because we are delayed the food, our mood changes. That sentiment analysis is what drives that behavior. So we have been doing this humanly. Now we just got to make sure that we are able to do that with a large data set using machines. And that is nothing but the entire machine learning and artificial intelligence that we are trying to do to implement that on a data that you collect over a period of time. These are the 5 different techniques that we use onto the data sets. Any questions? Anything like additional thoughts that somebody wants to add to that? More than happy to hear.
Nilesh, this inline data analytics or augmented analytics that you explained is something really amazing to know. But like we experience it, but how fast it is being done and how fast it gets the decision maker gets the data. So it's really amazing to see it.
Right. No, and some of those things has been provisioned. Okay. The best case scenario is less than second. Okay. Worst case scenario is about 5 minutes. Okay. Uh, so nobody wants to wait more than 5 minutes to get the analytical results that will augment my business process, right? And business processes have their own turnaround time and cycle times that they have to meet to, right? So there are variety of use cases where people have created inline analytics which gives you result in less than 1 second, right? ATMs are the classic example of that, right? All this data, whatever you are collecting from variety of ATMs, that gets processed, and somebody sitting into a cash distribution uh, department says that, okay, which is the first ATM that I need to make sure that I put a cash into, right? Though we understand that in certain geographies we have seen challenges of not having cash into the ATMs, but that is the logistical issues, not really the prediction issues. So predictions are done in a base case scenario in less than a second, sir. Yeah. Now some of the benefits based on my experience, right? These are some of the numbers that I collected over last 2 days. What I have seen personally working and where I have seen it doesn't work, right? So when it comes to the segmentation of customers or citizens, like we do, all the political parties go through that. Okay, the real value has been about 40%. Whereas when it comes to improving this quality and speed of decision making, there is a huge uplift that has happened because of the big data ecosystem, right? Uh, be it the credit approval, be it the booking of the airlines, or be it the price prediction for flights for, let's say, 6 months down the line, right? all of that, which is the quality and speed of decision making, that has been influenced greatly. Planning and forecasting is another area where we have seen, especially in a banking, healthcare, as well as high tech industry, that their ability to forecast and plan accordingly is greater. Uh, Nowadays, when the automobile industry, when I look at, I recently got the brand new car Aston Martin, and it was like so pointed marketing event that happened that I just could not resist. It just came on my doorway, and I said that, okay, this is the car that I must buy, right? So they know behavior so well that they plan effectively and forecast and predict that this particular product will be well accepted by certain population or certain individual. So they have been able to really influence that. Customer service is still an area which is growing and getting better results, but there is much more that can be done, and industries has been focusing on to that. We have done many projects into the customer services, especially with the healthcare, where the clinical or care delivery is a critical aspect into US healthcare, because about 47% of US population is governed or covered under Medicare, which is the government-sponsored healthcare plan, and Medicaid, which provides 70% from the government pocket, and then 25% from the individuals or insurance companies pocket. So the customer service really, which drives the utilization of the individual services, that directly impacts the organization's ability to sustain onto the cost pressures, is very important, and that is driven by the customer service. And then there are few more automated decision in a real-time process. It is still a area which is increasing and getting a good traction. My prediction, and I talk into variety of conferences as well as market researchers who reach out to me for my inputs. My prediction is that by end of 2026, the use of dashboards will be less than 2%. That only 2% people will use that dashboards or visualizations or tableaus and Power BIs and all sort of reporting tools. Nobody will be really putting money onto. So everybody will be looking at the real time, just alert my on my mobile, uh, something like, okay, well, your 10th number onto the queue, uh, and you, based on your current location, you should start driving in another 4 minutes. That sort of pointed analytics alerts is what people are really looking for, right? And these are some of the changes that is driving industry to invest millions and millions of dollars onto the big data initiatives. US healthcare, which is the area that I am currently working on to, uh, spends about $56 billion, is expected to spend basically $56 billion in 2022 only on healthcare analytics. Imagine the amount of technology debt that they need to eliminate, and the new technology that needs to be implemented. So there is no dearth of new problems to solve. Industry is open. It's just that who provides the right solution and who has the right engineering talent, they have been winning the businesses. Any use case that resonates with any one of you? Like, you can probably would like to talk about your experiences or anything. It's just to make sure that we are interacting with each other. It doesn't sound like a monologue. I hate monologues. Okay, so I will move to the next one. Now, when somebody like uh, a big data program starts, okay, so what life cycle it goes through? Now, industry has also moved from our regular SDLC life cycles, right? Uh, Even I am saying SDLC after like at least 10 years, I haven't spoken this word. People had moved on to the agile, right? And during agile as well, the agile got so bastardized that nobody follows the one particular framework. So there is so much of variation into the implementation of the projects, And that is where many projects has been failing, because consistency in an implementation has been so much varying that every time you replace the individual working onto a program, there is so much of rework that happens that directly impacts the success of the program. So it is important that you have to define a right strategy for your big data initiatives. My sincere recommendation will be, when you're delivering the lectures for your students, talk to them about strategic mindset, talk to them about why design is important. But before really talking about design, you need to understand what are you solving, why it is important to solve, when it needs to be solved, where it needs to be solved, and how it will be solved, who will solve the problem. That's the sixth one. They need to start thinking about it, right? Across three tiers. The first one, business process. What happens if I don't do this particular program? Is there a business process impact? Am I losing money? Am I losing the money because of the inefficiencies? Is there a growth challenge because of my business process are weak? So once people start thinking about what, why, when, where, how, then they will start realizing that design is just a fundamental to the mindset. So having a right strategy is very, very important. Be it business process, technology, people, and the last one, the whole pricing. Everything boils down in an implementation to a pricing. Uh, 6 out of 10 projects, if I lose, are because of the price, and price sensitivity is very, very high. Now unless you understand the strategy, pricing will always be wrong, right? So engineer really needs to start thinking from their education time itself, that how to really think strategically, not thinking about writing a piece of code. Writing a piece of code is the easiest thing to do into the IT industry. What is more important, that defining a strategy, then looking at the data. What does my data look like, right? Do I have even a data that the person is trying to solve a problem has seen the data or not? I am talking about improving the customer success or customer service, but I don't have the contact center data, I don't have a campaign data, I don't have the customer recent addresses data. Customer service will never get improved, right? So asking with the question, looking at the data set that you are looking to solve this use case, and for that use case, you don't even have the right data. And if right data needs to be collected, where that data needs to come from, right? There are only 11 segments of the data into the entire world. Data which is generated from your applications and products that you use to run your businesses. The logs of the individual applications and products that are generated internally, logs which are generated by the external systems which are used for running your business processes. Then there is a social data. There is all your legal documentation data, be it the insurance policy or be it the banking form that you have filled or an email that you have sent, all of that data. Then the call center data, contact center, which is all about the communication, voice data, sentiments, and all that a contact center agent can capture. Then there are supportive four data sets, which are financial data sets, which are your social data sets, which is about the norming data that every every government agency collects, be it all your the what we call the population counting data, census data, mortality data, all of that data sets, right? So all of that supportive data sets. Outside of these 11 segments, there is no other data set that comes into any businesses. So you got to understand, if I need to solve that problem, where this data needs to collect it from, right? And then once you get the data, ingesting that data into your ecosystem, right? Ingestion across the board is the biggest, sorry, is the single biggest problem that most of the industries are trying to solve. My ability to acquire data from somewhere and ingest that data into my big data platform is a big problem. Now we might think that, okay, what it takes to copy the file. It's not just copying the file, it is about taking the data, transforming that to meet your need, and making sure that that gels together with all other data set that you have, which is the integration, right? We all talked about this ETL part. So the transformation and integration is a bottleneck today into the big data ecosystem. People claimed initially that, okay, we don't need the transformations and we can just dump all the data into the data lake and we can use as we need. That doesn't work. Okay, it just becomes a junk repository, right? Every data set, if you just keep copying into one particular big database folder or the file folder, it is not usable. Whoever wants to use it, they have to spend their time on to preparing that data to be ready for the analytics. Surprising numbers that I will give you. Data scientists are the one who write the ML or AI based algorithms to predict the outcomes. They spend 80% time on to collection of the data and creating a data set that they can use for their models. Their job is not creating the data sets or arranging the data sets. Data sets should be pre-arranged so that data scientist puts all his 100% effort on writing the predictive analytics algorithms, right? And then comes the entire definition of the analytical process, how you will make sure that the whole 9 years about the programming, tooling, who gets the access, who should be the analytical results sent to, where those analytical indicators needs to be integrated. All of that comes as part of the analytical process definition. And then you get into the agile cloud operating model, big data projects. 8 out of 10 projects are big onto the cloud. There are still two projects that you will see out of 10 who are onto the on premises, and those are mostly using Hadoop, right? Rest everything is onto the cloud, whether it's a Hadoop or non Hadoop. But cloud means there are a variety of tools that are there. I I feel like the challenge that most of the IT workforce has been going through, the mindset of taking everything as a big project, right? If you can help us seeding that thought into the students' mind that pilots are equally important, prototyping is extremely important, rather than putting everything that you got onto building a large product and then realizing that, okay, this is not working, it is not scalable, it is not viable. Rather, I would recommend people to have the mindset of pilot and then incrementally realize that pilot into a full blown product platform or a solution. So taking a problem, breaking that into the smaller, creating a complete end to end critical components, or we used to call that into the project management critical path, onto the solution, what are critical path, and taking that smaller pieces and implementing a smaller solution to prove that yes, this is viable solution, data is accessible, it's safe as well as familiar, and meets all my 9 years about data security, privacy, retency, latency, and required indicators can be generated. So a pilot mindset is very, very important with the engineering. And then last one, which I was talking about, embedded analytics into decision making. No need of dashboard visualization. Nobody is going to look for them in a very near future. As I said, 2026, my prediction is less than 2% will use the reporting tools. And whoever is using, they are using just because they don't have the alternate tools then, right? So we should start planting some of those seeds into the students' mind that big data is not only about creating the reports, it is about how your data will drive the businesses and the processes within the organization. Okay, so we are 1 hour now. Okay, so some of our past experiences, how these projects really work, right? So it is important that roadmap has to be iterative. The agile methodology or iterative or scrum based or sprint based, whatever we want to call. Generally, it is important that you spend 1 to 2 weeks on analyzing the stakeholders, analyzing the strategy, and defining the right implementation strategy for your program with very well understood estimated cost. Uh, 4 out of 10 projects, which is 40% projects, are overrun onto the cost, and rest 60% overrun and ran onto the efforts, right? Which is not a good state for any IT industry. We struggle a day in, day out, by the way, with just effort, schedule, and cost. People just don't estimate it properly. So for big data projects, there is no out of the box estimation technique that is available, because the problem statements and problem from one piece to other piece varies so greatly that you can't really create a benchmark or even a function point to say that this is how the function point will take this much hours of effort. So big data projects do suffer for either underestimations or overestimations. If it is overestimates, project does not get kicked off. If it is underestimate, project gets kicked off, and then we ask for additional money. So the customers keep crying about that. Then spend about 3 to 4 weeks on a deploying the right business application. Identify which are my top priorities, which ones are my low hanging fruit, which will give me a better ROI. And based on that, then get into your uh, source identification, uh, right business processes, define the right business outcomes, use existing skills to deliver the program incrementally in a cycle of 7 to 9 weeks of cycles. So first phases, the this phase and this phase is one time, and then 7 to 9 weeks are the iterative way of building the component solutions and delivering that to the businesses or integrating that into the business processes, is how the roadmaps for big data solutions or implementations been practiced. And I have been one of the practitioner of this roadmap, right? Now, some of the data points for you guys to really understand that uh, there are two ways data is generated. One is a human who generates the data, and then there is whole multiplier of human generated data which machine generates, right? Since we have been onto this call for like 1 hour and 2 minutes, that's 62 minutes. The total data that teams generated right now, about 40 participants, is close to half a GB, minimum half a GB, right? That data is just what machine generated. On top of that, whatever voice recording that has happened, on top of that, whatever sharing of data that has happened, all of this data set really is what machines really generates over a period of time, and that is where the growth is going to come. So when somebody asks me that, okay, what should be my capacity planning for the infrastructure, I look at them and say that, okay, just be open to put more money and more scalability for your hardware. That is where the cloud comes into the picture. So when you talk about big data with any practitioner or any students, you need to make sure that you explain them that big data requires a massive computing power as well. And that's why people have been moving from on premises to the cloud infrastructure, so that they don't have to provision the servers, they don't have to worry about the horizontal scalability or a vertical scalability. I should be able to add as many systems as I want with a single click, and each system should be scalable from the memory processing power standpoint vertically as well, that I should be able to add memory to that, I should be able to add capacity, storage capacity to that, as well as the processing power to that, right? So that's why the clouds are becoming very, very important into big data world. And it is expected that every application is going to keep on generating higher and higher number of data. Now, this is just about the computers and PCs, but there are about 12 to 13 billion smart devices which are connected to the phones, right, or connected to the computers. All of that data also comes onto the ecosystem. So when somebody thinks about building a solution, they need to start thinking about, okay, what is my potential data storage will look like? What will be my storage strategy going to be? Because not every data gets used at every incident, right? So how you will store the data which is most active or most recent into, let's say, hot store? How will store the data which is not really required for my immediate analysis, but may require infrequently, will sit into, let's say, my cold store or warm store. And then there is all data which I don't really need, but if something needs, I should be able to get that data back, then put that data into the archival. So all of that, the design strategy as well as storage strategy is very, very important, because machines are going to generate more and more data. Right? Now, this is how the overall reference architecture of big data ecosystem initially got envisioned, right? And this is Hadoop centric. Okay, there is.
Nilesh, I have a question for you. Like before you start on this architecture, education tech segment or education domain, academic domain, this machine learning or this analytics, how it will be helpful in education domain or academic domain?
So, see, tech is very, very important. I have invested heavily onto that side. I have three companies where I have invested into the education technology, or aid tech is what we call. See, the more and more online delivery of content, okay, and the engagement is going to drive bigger analytics. So, for example, Magic Pfizer is a company where I have invested. They have a technology platform through which they provide the corporate as well as non-corporate training content, and they delivered it, right? Some of those are online, some of those are offline. uh, they generate huge amount of data, and for them there are three things that are important: whether the quality of content is right, whether the intended content was delivered in a seamless way or not, and that gets evaluated based on the responses that you will get from the consumer, the recipient, right? So there is whole chain of capturing that data as well. There are feedbacks, there are chat windows, chat bots, there are trackers, how much time somebody has spent onto one particular slide also shows whether the content was easy to deliver or was difficult to digest. So there are attention span related metrics that they capture. So there is whole 9 yards of edtech which is getting used for determining the quality of content, the delivery quality of the content, and then usability of the content. That's the first part onto the qualitative side. And then there is a quantitative side: how many members are there, how many students are attending, how many of them stop the training in between, what has been their responses, all of that, which is the quantitative side, which determines whether a particular content which was really provided from the platform should get paid incentives or not, because all this material that they buy and then they deliver it, right? So there is a full financial aspect as well as the educational aspect that comes into the picture onto the aid tech side. So huge growth you will expect onto that side as well, and they are already doing. Vedantu does a brilliant job on predicting the population who will be attending the particular training session based on the past data, looking at the content as well as looking at the individual uh, who is delivering the content. Hope that answers your question, sir. Hello. Okay. So moving on. So when you look at the overall architecture of any big data ecosystem, so there are, on the left hand side you got all your sources, right? Be it the internal sources, external sources, the sources that you control and the sources that you don't control. Then there are cloud applications, enterprise applications. All of those becomes your sources, right? From sources, the big data ecosystem that you are trying to develop, okay, has components like, let's say, EDW or a data lake. There are in-memory databases, which gives you ability for you to process data in a memory rather than increasing your IO operations. Then there are analytical appliances that you can deploy onto something like, let's say, ThoughtSpot thought analytics, one of my company, right? All those appliances. There are ODSs that you can develop. There are cloud data warehouses like a Redshifts and other thing that you can do. And then there are NoSQL databases. Like all these, based on the type of data that you have, you try to develop. But before getting here, it is important that you need to understand that all this data has to be ingested into your big data ecosystem. That is typically done using either scoop, ETLs, or change data capture techniques, which allows you to get data into the batch, incremental, real time into your big data ecosystem. When it comes to real time, there is nothing called real time, by the way. Okay, well, let me clarify. Everything is a near real time because the lag can be 1 second, lag can be 10 seconds, lag can be 1 hour as well. And depending on the patience of an individual, the real time definition changes. I had a customer who said that, okay, you said real time, I click the button, but that data is still not here. I said, there is still a transportation time that is happening for the data processing time. He said, no, then this is not real time. So it is important you clarify anybody that you talk to. There is nothing real time. Everything is a relatively near real time, right? So near real time data, which we call as a streaming, that you can get from tools like using Plume, Kafka. Then there are Spark streams and there are Scope streams. There are many tools into that, right? So essentially, you get the data into the ecosystem based on the type of the data. You have either batch, you have data warehouses, you have simple SQLs, which is for the rendering, right? Uh, or you can have your something like Solar, which works on top of the massive parallel data operating systems where you can run at any given second millions and millions of queries that you can run across all the clusters that you have, right? So this is the ecosystem that Hadoop brings. This is the ecosystem that your data warehouses as well as on-premises or cloud-based ecosystem that brings. But ultimately data delivery happens. So there are use cases that you get the data from your sources, real-time processes or near real-time you process it, store it, augment that with your analytical appliance indicators and send that downstream, which is nothing but the alerts, right? So those use cases are very, very common and that happens. I can give an example. So, and it is easy to understand from the healthcare standpoint. So let's say an individual goes to a doctor. The first thing that happens that they take the insurance information, they check you in. The moment they input the insurance thing, they send a request in a real near real time to an insurance company to validate whether an individual is covered and is eligible for type of services that individual is looking for. So that process is called as a prior authorization. The moment that goes to the insurance company, they validate it automatically. That information gets processed and then they send the information that how much copay, which is an individual needs to pay to a doctor, and how much insurance will pay for the service, right? That is called as the post authorization. That information that doctor needs to get. Now imagine that I am sitting into a hospital waiting for my prior authorization, post authorization amount. If it takes 10 minutes, 20 minutes, 30 minutes, 1 hour, will that work for an individual who is going to the emergency room? No, because there has to be first services rendered. So that near real time is very, very important, where latency is expected in less than 30 seconds. That once I send the request, the entire processing and alert that prior authorization approval needs to come. We call that as 271 request and 272 as a response, right? Which is nothing but the entire integration, real-time integration that we do using these big data appliances, right? Then there are use cases like a reporting, data discovery, self-service sort of things, which are NLP based querying techniques. And then there is predictive analytics, statistical analytics, text analytics, or data mining, that sort of techniques that you employ onto the big data ecosystems, which can be run onto the data warehouses or it can work onto the directly Hadoop cluster, which is if you really look at, right, and logically try to analyze what HDFS is, it just massively parallel system of what we used to call as a D-base. Ultimately, that's the only way to really get to the roots, that in the past we used to have a D-base as a technology, right? Uh, it was a file system. Using that file system, they just created them parallel execution with unlimited capacity of hardware attached to it. It became the HDFS. Okay, just that, okay, it got some Parquet file formats and some new formats that they introduced, but concept still remains same, right? So all of the mining typically is done onto the Hadoop HDFS file systems. Any questions onto the reference architecture? Okay. And each of these boxes have their own topics, by the way, and there is so much of material available. Change data capture. Okay, if all of our students understand, okay, what change data capture means, trust me, IT industry will be so happy to have those sort of engineers into their their table who understand the change data capture from day one. ETLs, there are a ton of knowledge base available. Scoop is similar to taking just a big size of the data from the source and just putting that into the different bucket, right? It's just a scooping technology. It just copies files from one place to other place. It is as good as file transfer utility. It just gives you some flexibilities of breaking the files, encrypting the files, applying some low level transformations, but it is still a file transfer, right? Sorry, go ahead.
Or it's like tools transfer
Sorry,
things.
sorry, couldn't hear you. Can you repeat it, please?
Sir,
Hello.
as you said, EL, ETL, and it's all a tool for splitting up the files, big files into smaller. It's like tools, or we have to. It's like any library.
There are many techniques. Okay, depends on what type of tool that you are using, but there are techniques to split the large volume of files, okay, into the smaller ones. We just proposed our architecture as on yesterday for a large payment integrity company who gets per minute 50 million claims across the world that they process, healthcare claims, and everything comes into one file. And we said that, okay, if you're taking that one file and processing through a complete channel, your cluster will get clogged. So it is better that we split the files. Now there are, depending on the type of file and the construct of the file, right? Some of the files could be just columnar database. Some of those files will be nested XMLs, right? XML within XML within XML, right? And then the lowest node is the individual data unit. So depending on the type of file, you have the splitters available, right? So XML file splitters are there, EDI file splitters are there, flat file splitters are there, database batches splitters are there. You can put the threshold. Let's say I want to process only 1,000 record batch. So you can do that. You can certainly do that. And it does not require specific tools. It's just a configuration or some additional line of code that you typically integrate into your ETL processes.
Okay, sir. Okay, thank you.
Okay. Yeah. Now, if you move away from the reference architecture and start looking at the technologies, right? Hadoop is one of the reference architectures. Azure has its own reference architecture, right? So again, all your devices and streaming data, which consistently and continuously generates the data, right? Then there is unstructured data, which is all your images, video clips, documents, PDFs, whatnot. Semi-structure, something like a JSON files, XML files, comma separated files, or even tab delimited files, all of those, or even a fixed width files, right? Then you have the full array of all your relational databases, which are your sources. And then there are other Azure data services. If you got any additional data sources coming from your Azure deployed applications, products, or even some of the devices that you have connected to, all of that data. There are three ways you can take the data for all your real-time data. There are something called as a Azure Event Hub or Azure IoT Hubs. These are the two tools that Microsoft Azure provides that you can leverage to bring the data into the ecosystem. Then there are pipelines. Okay, all these pipelines are called Azure Data Pipelines, which is configurable, as well as you can write simple Python type of code or even a .NET code to get data from all your unstructured, semi-structured, and structured databases or data sets through the pipeline. There is a tool or component that Azure provides, which we call as Azure Data Lake. We are there are many places who call we call that as a Delta Lake as well. Azure Data Lake or Delta Lake both go interchangeably, right? Once your data from the pipelines you move here, you can also have all your streaming data using Lambda architecture. Lambda is a technology where you can write similar to the C++ we used to write functions, right? Functions and processes. So similar, Lambda gives you ability to write the functions. Those you can apply onto the event data sets and push that data into the data lake into the desired format that you want to push to. From there, now, as I said, that you need to send this data, let's say, to the stream somewhere else. So you can directly pass on that data to the stream analytics, which is the inline analytics or a real-time analytics that you can generate out of which. If it is based on your uh, at-rest data, which is the data platforms like a data lake, unified data hub, data warehouses, data marts, then you can move data from this data lake to the respective tools like a Explorer pool, or you can put into the Sparks pool for analysis or warehouse sort of scenarios. Then you got the data lake analytics like a Synapse, which is a serverless. Now this is a big concept that I want to touch on to, right? So there are three type of architectures that IT industry really uses. So first one is a event-based architecture. That particular event happened and data movement started, right? Then there is a server architecture, which a compute is always on. That computer is always processing something, even if there is no data moving, computer is still doing something and running. So you are utilizing the compute power. And then there is a third one, which is a serverless. So combining your event as well as the server architecture and making it serverless, that whenever a particular event happens, my server kicks off, does the processing, and then shuts off, right? I don't lose the data, nothing changes. Okay, practically it just means that, okay, you are paying for the use of the infrastructure. Now the serverless architecture became very important because many places you were just not able to predict the number of users at given point of time, right? Somebody will come at 7, run the report. So you can say that, okay, every morning 7 a.m. somebody runs the report. So you will make sure that server capacity is very high. Let's say 50% of that user on that particular day did not come and they came at 12 and they ran the report and my server is not running or my server is not having enough capacity. So those were the issues. So what Azure, basically it started with AWS and then Azure copied it. They came with a concept of a serverless architecture, that every time you run something, my server will become up, will process is complete, my server will get into the resting position. I will not charge you for that rest of the time. I will charge you only for the time you used my infrastructure, right? So that's serverless architecture. So these are used for data warehouses or T-SQL sort of requirements or needs where somebody is going to query the databases. Rest everything is mostly server architecture, not really the serverless architecture. Now, when it comes to the streaming, you can push that data to enrichment for cognitive services so that you can run all your machine learning algorithms. So typically what happens, all your streaming data goes into the cognitive services. All your big data sets are also pushed into cognitive data services, where you run all the machine learning algorithms. Sorry, my bad. Right. So machine learning algorithms, Azure provides its own set of library. And on top of that, you can write on all your new libraries as well, or new algorithms as well. And then there is whole 9 yards of about your Power BI reporting, Cosmos BI DB. You can create and send the data to some other applications, or you can send that to the sharing in terms of file databases, or even some of the messages, right? Across the board, there are these components which are very, very important to understand, that there is Azure Active Directory integration that becomes very important for the security standpoint. Cost management tools are important to make sure that you are not overpaying for the infrastructure, because cloud cost can go up just like this, right? We started an engagement 4 months back. Uh, Engagement was into 11th day, and customer got the bill of $250,000. Customer says that I am not paying it. This is your mistake. You should have managed the cost. So that becomes a big issue. So there has to be a better way to manage it. Then all your password protections, monitors, security center, all of that are the administrative tools. But the most important tools that are for the engineering or engineers, or data engineers to understand, is the Azure DevOps and GitHub, that they need to make sure that they understand and they learn. DevOps and DevSecOps are very, very important from the data standpoint. And then there is a Azure policy, all 9 yards about the security policy, provision, good data governance, all of that, that falls under the Azure policy. This entire thing we club together under the governance called Azure Purview, right? So Azure Purview take care of most of these things that people need to understand how it works. Any questions on this? And this is one of the very, very detailed architecture that I tried to do. Uh, there are still 3 layers more you can go to define each and every line becomes its own solution. Any questions? And these presentations are with Manish sir. So Manish sir can really give you these presentations, which you can use for your further references as well. Now, similar to Azure, there is AWS, right? Another cloud service provider. Their architecture remains same. It's just that the technologies do change, right? So the way all your data sources, sorry, yeah, are clubbed here: logs, application, data, all of that. Then there are relational data sources, other databases, on-premises databases, S3 where all your documents typically are stored. All of that you can push using Azure Glue Studio, similar to ETL tool, or what I was showing on a previous slide, the pipeline. Azure Glue Studio has ability for you to set up the data pipelines. SageMaker notebooks are used for data sciences purpose. Data Brew, AWS Data Brew is used for scrubbing and mingling the data or integration of the data. Uh, AWS Glue again has ability to provide you the filtering capabilities. Elastic Views has ability to create graph databases for you. Then you have the Amazon Redshift, which gives you the massive parallel processing data warehouse database. It's an appliance. So, and it's a serverless, so that you can, till the time your query is running, you will pay for that. And once query is executed, you don't have to worry about what compute it used. Whereas the job orchestration is very, very important. In a previous diagram I showed you, right? The entire Azure monitor who manages all your pipelines and scheduling. Here it is done by the managed workflow, Apache Airflow, right? So Airflow is another tool which gets used to schedule everything, every job that you are trying to execute against this cluster. And then there are targets like you can push data into the RDS, databases, or S3 file systems. This is simple and easy to initiate architecture. It just requires 4 clicks onto AWS to set up everything that you are seeing onto the screen, and then you can start your program onto that. There are out of the box Delta Lake or data lakes onto AWS. You can just spin up a cluster and it sets up everything. So all your ETL tools are set, all your databases are set. You can start creating the tables, you can start defining the structures, you can create the ETL code, you can create the reports or start writing the data sciences algorithms. So all of that comes out of the box with AWS as a AWS data lake or a Delta lake. I'm going to skip this for now. Okay. Important to understand the big player who is coming up and considered to be one of the finest to be data platform is a Google. Okay. So Google has invested enormous amount of money and energy into getting into the big data ecosystem. So they've got a tool called BigQuery, okay, which is the heart of your uh, big data platform onto the Google. So real-time events you can get using App Engine, which also take care of application data. Cloud pubs up asynchronous messaging is a tool which works similar to, I don't know if you have heard about tool called RabbitMQ. So RabbitMQ was another messaging tool that we used to use in the past. Now everybody has moved on to the cloud pub-sub model where streaming pipeline can be pushed into. Cloud data flow is a parallel data processing similar to your ETL tools, or currently that I was talking about the data pipelines into Azure or a glue into AWS. So similar to that. There is a separate stream that comes from the batch load, which is the large data set, one time incremental, all of that. You push that into the cloud storage. Cloud storage is similar to S3 of uh, AWS and also similar to Azure Blob storage. So if somebody says that, okay, where do you store all the files onto the Google Cloud? Everything goes into the cloud storage, right? From cloud storage, you can push that data using data flow into BigQuery, where you can define your data models. You can have columnar database or even a schemaless database. Whereas you can also push data using data prep tools, okay, visual data preparation like a ETL tool. Here you do the scripting, here you do the configuration. So example, C++ based ETL code or Java based ETL code versus Informatica based configuration of the ETL to push data into BigQuery. So BigQuery is nothing but a data lake of a Google Cloud, right? From where you can run all sort of your visual analytics, BI tools, Google Sheets, which is again the Excel sheet, kind of extracts, or you can have multiple user working onto the directly BigQuery, right? But Google has its own set of data sciences library and ton of algorithms open source available for you to leverage. So my 2 cents will be this is the space to watch out for Google Cloud in next probably 24 to 36 months. AWS is going to lose substantial market to Google, especially into the healthcare as well as the retail industry. Any questions? And we got 27 minutes left. I want to walk you through one case study. So this is a program that I architected and got it executed. So by my role, I'm a business leader. I stopped doing technical activities like 7 years back, but technology is still a passion. I don't code anymore, so I run a business for a company called Emits. So I'm a chief data strategy officer. This is one of the case study that we implemented, which I had sold. I had envisioned the architecture, and then my team implemented. So Cotiviti, okay, and you guys you can do the Google as well about Cotiviti. So Cotiviti is a data aggregator. So what they do, uh, healthcare insurance companies, which we call in US as a payers, right? Who pays for the services for their covered patients or insured patients. So they contract with payers. Payers provide them all the claims, membership, and member data. Member is nothing but a patient. All that data. Cotiviti ingests that data into their platforms. From there, they run variety of algorithms to identify whether the payments that were done were right or not, whether there was any propensity of fraud, waste, abuse, was there underpayment or overpayment, is there a recovery or collection required. That is one side of the business. Second side of the business is a risk adjustment and risk stratification, looking at the claims data, identifying the population who is the risk prone, whether it could be a diabetic risk, chronic conditions, non-chronic conditions, high cost, high claimant, no shows for the visits, variety of risk that they predict. There are 498 different risk indicators that we generate onto that claims data. Then there is different product line called population health management, which is about reaching out to the population or the individual members to make sure that they are healthier, to make sure that they show up for their visits, to make sure that their cares doesn't have any gaps, making sure that their vaccinations are done, making sure that they don't fall sick, making sure that they don't do the readmission to the hospitals. So variety of risk management that they do. And then there are other 17 likewise products that they provide to the payers, services that they provide using those products. Their problem was all this data was scattered into that many different products. They were having 490 people sitting somewhere in a Nepal and close to 600 people sitting into Pune who were managing all these data intake processes day in, day out, spending about $120 million every year onto just managing all these data sets. So I met them during one of the conference and they just said that, okay, these are the challenges that we have, uh, how you can help. And that's how we help them developing this product called Caspian. So I just visualize it, showed them that this is what can be done. So Caspian today is United States single most largest healthcare big data platform, designed by me, implemented by my team, right? So Caspian is a unique in a variety of ways, not only from the data size, but also that it is most complete data set. Every other possible data attribute that can happen within United States, we have about that particular member, as well as all the claims, clinical data, their pharmacy data, social data, their employment records, all of that data we gather together to create that unified storage. Why it was important, right? Like it's okay. So what happens if there are 17 products, 17 products has their own data? What is the issue into that? It's a fair question, but imagine that they are spending their 40% of revenue on managing a data operations. They will never be a profitable company, and everybody wants to be a profitable business. So in order to make the company profitable, in order to give the edge for them to onboard customer faster, in ability to launch for new products within 30 to 60 days, which was originally anywhere between 12 to 16 months, all of that were enabled using this platform. So it is not only about gathering the data into one particular repository. It is about enabling the organization to grow, to save money and become a profitable while becoming a purposeful for the population, whoever uses that platforms to get the services rendered. We were able to reduce their 70 to 80% of client onboarding time from 14 to 12 to 16 months. We brought that to 30 to 60 days. Any question? I thought somebody has a question. Okay, right. We were able to predict the chronic conditions and predictions. Sorry, go ahead. I thought somebody had a question. Okay. So we were also able to influence their member churn. Member churn is a very big problem here actually. So what happens, let's say I have an insurance policy from, let's say, Aetna as an insurance provider. If I leave Aetna and go to Cigna, the another insurance company for my health insurance, Aetna not only loses me but also loses the edge to the Cigna, because Aetna will have to share data for the Cigna. So whatever effort that they put on to making me healthier, right? Cigna utilizes that benefit. So how to really avoid a churn of a member is very, very important for them. Eventually, we proposed them a solution and implemented this, okay, which we call Caspian today, which has uh, right from strategy definition to a conceptual architecture to metadata driven ingestion. See, metadata management we learned when I was in my MSc. Okay, so it's not a new concept from the theoretical standpoint, but practically very few people had implemented it. Now industry started adopting to that metadata driven frameworks, low code, no code frameworks, so that you don't have to write too much of lines of the code and reduce your time to market, right? Then we developed the MDM solution as master data management to identify uniquely a individual, be it a patient or a provider, basically physician. You should be able to identify who provided services to whom. And then the data lake framework with a common data structure. So we created a unified data model, all that, which resulted important, right? So this project went on for 12 months in a development. 90% of client data we bought into the data platform in less than 4 months. Look at this number of jobs. 6,274 jobs are executed every day 3 times, right? There are 15,333 data sources coming from external world, right? This was my peak team size 70 people. Current team size is 45 resources. Okay. And it was a milestone based pricing, which is agile based with a skin in a game, that if we would have lose any or missed any milestones, we would have got the penalties, right? Today, this is the status of that. So 2/3 of US population data is into this repository, 220 million lives. So the total US population is about 230 million. Yeah, 200, sorry, my bad, 330 million to 340 million is the projected population of US. Out of that 220 unique patients data we have, there are 160 billion number of claims, medical claims, their pharmacy claims, 102 billion lab records, okay, with a 5.5 million provider records, which is a unique physician information, who provides what of services from what addresses with what tax ID, with what their billing charges, what their credentials are, what their licenses are, where other places they do practices, all of that information. So anything that US healthcare needs from the identifying the doctor, they come to this database, which we build for one of our customer, Cotivity. Okay, these are some of the high level benefits that we were able to deliver. We were able to identify diabetic case prediction. Now imagine this way, that every person in US has about 78% probability to become diabetic, right? They just don't know when. With our algorithms, we have been able to predict to a greater degree the time to event so that you can avoid it. Because each person falling prey to diabetic has potential to have an impact on an insurance company anywhere between $300,000 to $1 million, right? High cost, high claimant. Very, very important to find out, okay, who is going to be my potential most expensive patient to avoid any cost implications. And there are 850 my bad, 487 health plans, which are insurance companies. And then there are administrators, which are about 400 administrators into United States. So all put together about 840 companies who needs to know who is my potential high cost, high claimant into this population, right? And then there are other benefits that we were able to drive to, right? This is one of the most spoken case study into United States healthcare, what we have successfully delivered, and this was the architecture. So there are data sources which are file based databases, batch and streaming, right? All of that. We used technologies like Flume, Kafka, Scoop, Flink for file inspection when the input file comes. We use entire Java, Scala, JavaScript, okay, based entire configuration metadata driven engine. For workflow and orchestration, we use Airflow. When it came to file format adapters, variety of formats to be converted into one singular format, we use TIBCO. For validation engine, we use Spark. For all transformation, we use Sparks again. Spark is again an extension of Java, okay, sophisticated Java basically. Data is stored into three different zones. Raw zone, whatever data format that comes, we store that as is into HDFS. We give on top of that Impala as the interface for SQL so that somebody can write the SQL queries to retrieve the data. Refined zone, again HDFS, Impala on top of that, and we also have Hive there as well as Yarn to manage the overall Hadoop HDFL system. Production, where we have most refined data with the best quality with all MDM integration done, master data management, which is developed using Spark and Scala again. Sorry. Okay. All metadata is managed using Cloudera Navigator and Hue. Data management is done using Cloudera Navigator and Hue, all about the governance, security, privacy, all of that. And then we are using also KMS and Sentry as two tools to manage the security. And all operations, data operations are done using Zookeeper to manage this entire cluster of technologies to deliver the uh, seamless experience. Any questions? Okay. So that is what I had from my side. Open for any questions, any concerns, or anything that additional I can explain or talk about. Okay. So I think nobody has questions. So Manish sir, over to you. Hopefully this was helpful, some informative, uh, in some shape form, might have given some information. If there is anything additional that you need, you can reach out to me through Manish sir. Uh, we'll be more than happy to help.
Uh, Hello, Nilesh sir.
Yeah. Don't call me sir, please.
Hello.
Don't call me
Okay.
sir.
Hello, Nilesh. Really a very wonderful session, and I'm very happy to hear you on this topic. But the problem in India is like there's a huge gap between academia and industry. So whatever researchers are doing, industry is very far in terms of implementation. So when we talk with this big analytics, whatever you delivered today, so can you suggest something or some areas where we can meet this gap?
Yeah, so no, certainly, and there are from the researcher standpoint as well as from the academics and organization. Okay, there are three use cases that I would strongly urge you can really look at. So first one
Hmm.
is the entire COVID data set that has been used or got generated, right? And this data set is available, by the way, for to the researchers. If you look at that data set and predict, okay, because these vaccines are not one time, Okay, you are going to take that every 6 to 12 months, right? Use data to predict, okay, who is most likely to get the vaccine on time. Okay, looking at that data set. Now, the research component, okay, and also helped hospitals and the vaccine delivery team to say that, okay, you need to plan for that. Okay, a very good use case, doesn't need much infrastructure, we can make available. Those are mostly like for research purpose. You have those available for the educational purpose or the academic purpose. You can use GCPs or Azures, which are open to give at no cost. You can use that. There is other way you can do the corporate types, by the way. Okay, there are we have a MOU with university. Okay, with our North Maharashtra University, where uh, I have certain startups and other things that I keep running onto the parallel. So under that MOUs, I can give the projects, you guys do it and deliver those, right? So that way you will also have some practical hands-on experience or as well. But
Like you mentioned, sorry, like you mentioned, you are working with the dentistry field. I'm also working in that field.
Okay.
So I am trying to implement a diagnostic tool for the dentistry that will actually help the doctors to identify the classes of maxilla. Because in India, the trained doctors are very less, and they are primarily available at the tertiary care centers only. And but I am not working with big data and all these things. I'm basically working with the ML and image classification kind of thing. So as you have already worked on this area, so can you quote some challenges that I could face while working with this area?
No. So there are certainly 3-4 challenges which comes in mind. Okay. So first one is the quality of the data. Okay. Whether you have the right data set with all the required information or not, right? So the whole uh, all 5 parameters of the data quality, which is the correctness, uniqueness, right, usability, and this, right? So all of this. So that is one aspect that you will have to keep very close watch on to, that how you are going to make sure that data required for your models to work onto is made available. That is number one. Number two, see, the correctness of these predictions has to be validated and relearn. Okay, and especially when it comes to healthcare, right? Larger impact onto the individual, right, as compared to the financial institutes. Eventually financial institute is going to lose the money, but in a healthcare, and especially dentistry or even the urology, for example, these are the two domains where even in US healthcare, we say that whatever predictions are happening are about 60% confidence, right? Till the time there are enough people to progress the confidence factor. Okay, everybody says that 95% confidence factor is very, very important, right? Which is the Six Sigma principle as well, right? But 95% confidence factor requires a large data set for you to prove that, right? And in India, the population going to the dentist is substantially smaller as compared to the whole population set we have, right? So the challenge that we will have, the improving the confidence factor onto the predictions that are happening. Okay, whereas talking about only image processing and image reading using ML AI, okay, and then showing to a doctor a summary of an image, entire thing, right? Then it's different thing. Okay, so data sciences versus machine learning, the confidence factor of machine learning is much higher. Okay,
Much
not on
higher.
the,
Okay.
okay, the data is not a quality of data, the quality of image is the challenge.
Yeah, that is the yes, that is the main thing, because in India, if somebody is facing a dental problem, so it is not a major problem. So and moreover, the data set is not available. That is the major issue we are facing in our problem.
There are three data
So
sets.
thank.
Three
Okay.
data sets you can probably subscribe to. Okay, I will just send email to Joshi sir. Joshi sir can circulate that. So there are three open data sets available, the global dentistry data sets available, images, which you can use to train your models.
Okay.
Yeah.
Okay.
There are about 3 to 4 million images available. Then there are additional surgery data is available. A lot of things are available into that data set.
Okay. So particular data set is available for head and neck cancer patients because for that patients sometimes the whole jaw is removed or some partial jaw is removed. So if such kind of data set is available, kindly please mail that also.
So I can forward you what data sets I am aware of. Probably you will have to go
Okay.
through that and then validate whether those are useful for you or not. Right? Every use case is very
Okay.
unique.
Okay. Okay. Thank you, Nilesh. It's really wonderful session and it's really good to hear you.
Thank you. Thank you.
Okay, so any other questions? So Nilesh, it was a wonderful session. Like you are in like investor also, and you promote or motivate entrepreneurs to start up, to go for startups, and then have into business and be employer than looking for the employment. So that was like motivational also, and the it is also pride for us that you are the chief architect of the software or the framework that is being used in United States to give service to more than 60% of population over there. So it was wonderful, and it shows the depth that you have, and it is reflected from your talk. So thank you very much. It was a wonderful session, as Madam also explained. Thank you very much, and we look forward to interact with you. I will share your presentations with the participants, so they can also interact with you whenever they have some problem or queries. Thank you
Sure.
very much.
Thank you. My pleasure. Thank you.
Thank you, sir. Uh, so we'll start the next session at 12:30. I'm not happy, like many of you were not present when we start at 10 a.m. It's like we are not asking you to start the videos. We are not saying that you should be on in front of the machine. At least you be there so that the resource persons who are coming from long places, like he is joining from US, where it is Thursday night for him, and it's 12 midnight for him. And he was waiting for all of us, and we were coming late. And so I have a list of those who have joined late, 10 after 10:05. So I don't want to post this on our group. So make sure that you join, because tomorrow also we will be having a speaker from South Africa. Uh, he will join at 6:30 a.m. For, it will be early morning for him, so that he will be addressing us at 10 a.m. So we should not do injustice for those who are giving their time, and these people or these resource persons are really making time for us, and I think we should be serious enough to join on time. I think I should not talk more than this. So be join at 12:30. Let us join at 12:30.